Okay, I also have opinions about what makes a good presentation. I'm going to take Andrew's mediocre presentation and offer an even worse presentation, because this is just my web page, or the web page for the course. So this fall I'm offering a topics course, 489. There are a number of different 489s, right? This one's on neural networks. So full disclosure, I'm actually pretty new to neural networks. So this course might be a little rough around the edges. It's sort of one of these first offerings that I'm making available to undergrads about this particular topic. So I'll be learning, you'll be learning, and hopefully we'll all be better people afterwards. So neural networks, they're hyped up quite a lot right now. My interest, I should say from the outset, my interest is in the brain principally. But it's just that neural networks, at this point in our history, neural networks for the first time are really starting to tell us a lot about how the brain works. These deep neural architectures, these deep convolutional neural networks, hierarchies. So this is starting to, in my opinion, starting to look like what our brains actually do. So for me, it's exciting, and that's why I've sort of have dived into this neural network stuff. So anyway, I'm going to, my take on it is we're going to cover the standard neural network stuff, but in addition, I'll bring in some more biological, neuroscience-y kind of stuff as well, sort of approaching from that angle. So the prerequisites, CS 370, and a stats course, basically. So we'll be doing scientific computation and a bit of statistics that's sort of built into the whole, you need to know what distributions are and things like that. But nothing really crazy heavy. So by the end of the course, students will be able to do that list of things, essentially be able to simulate neural networks on a computer, write a program that trains a neural network, be able to formulate neural learning as a gradient descent optimization problem. That's kind of the bread and butter right now of neural networks. So we'll look at that sort of thing. And also, the last one, identify some commonalities between artificial neural networks and the brain, and how they might tell us something about how the brain works. So some assignments, a midterm and a final, standard in that sense. Mostly assignments, though. We'll be programming in Python. So it's free, which is nice. And a lot of neural network coding actually happens in Python. That's sort of the lingua franca right now of neural networks. So then there's a whole list of topics. I won't go over them in detail, but this is just a web page, so you all have access to me, just access to this through my web page. So just Google Jeff Orchard and go to my teaching page, and you'll see CS 489 listed as one of the courses. But neurons and synapses, and then we'll go into supervised learning, autoencoders, perceptron, associative memories. We'll spend a lot of time talking about backpropagation. Then unsupervised learning, RBMs are maybe a little bit dated now, but we'll cover them anyway. Then some population coding. This is topic number 4 is something that's sort of something we do at Waterloo, which is a bit different than what other people do. A different philosophy for neural networks than most people do, but we're good at it here, so I'll talk about that. And then a little bit on convolutional neural networks, recurrent neural networks, and then finally do a bit of stuff on, this is sort of where my research is right now, on sort of feed-forward, feedback neural networks. Like a lot of the big networks that are making news, like ImageNet and AlexNet and all these things, they're feed-forward. But your brain is clearly feed-forward and feedback. So these are models that are kind of more biologically realistic, and that interests me. And I think they'll be an important part of neural networks going forward in the future. There, thank you.